I'm coming over.
The year was 1965. Astronaut Ed White was the first American ever to venture out of the safety of a spacecraft. For 23 minutes, he was the spacecraft, conducting the first extravehicular activity, or EVA. Many more would follow. Astronauts donned spacesuits to explore the moon during Apollo, to perform repairs in the first U.S. space station, Skylab, in the 1970s, and to perform awe-inspiring feats from the space shuttle, from flying in space untethered to capturing a faulty satellite by hand.
Houston, I think we got a satellite.
But the greatest challenge for spacewalkers lies ahead, with the assembly of the International Space Station. The biggest spacecraft ever built, astronauts will assemble the station in Earth orbit, largely by hand, assisted by a new generation of space robotics. Hundreds of cables and lines carrying power, fluids, gases, and communications will be manually connected during 75 different spacewalks, for a total of over 500 hours, more spacewalking hours than NASA has conducted in its entire history. It will be one of the most exciting and difficult challenges ever confronted in orbit. For almost the past decade, NASA has been preparing for the new era of EVA, an era where astronauts will turn Earth orbit into a hands-on construction site. Special tools, techniques, and equipment have been designed and regularly tested in space as NASA has geared up for the job. One of the first challenges to overcome was the location of the work site. The space shuttle will carry its orbital construction workers 250 miles above the Earth, where the astronauts assembling the station will encounter new temperature extremes.
For space station, I think we've had to test to in the neighborhood of 150 to 175 degrees below zero, and in the other extreme it can be 200 or more degrees above zero.
To prepare for station construction, spacesuits were redesigned so that astronauts could lower the cooling in the suit during the frigid orbital nights and activate fingertip heaters in the gloves. Astronaut Mike Gernhardt tested the improved suit.
For a short period of time, about 25 minutes or so, I was up on the arm in the coldest possible place on the shuttle, and it turned out these modifications were wonderful. I was completely comfortable.
To make better work clothes for astronauts, new helmet lights, new tool holders, and other improvements have been added to the spacesuits. So some spacesuits can remain on the station for maintenance tasks. A resizing capability has even been added so different crew members can fit into the same suit, saving space and lowering costs. In addition to suit enhancements for spacewalks, a variety of power tools, pliers, and wrenches have been developed, specifically designed for the nuts and bolts work of station assembly. NASA also has addressed the problem of how to carry those tools across the length of the station, which is equal to the size of a football field.
We needed a more efficient way for the crew members to be able to transport themselves and tools and repair parts around on the outside of the station. And I sat down with the station personnel and basically on the back of a piece of paper sketched out what eventually became the CETA cart, Crew and Equipment Translation Assembly.
In 1991, 3 versions of the cart were tested in the shuttle payload bay, one even resembling a railroad cart. The final decision was to use the manually powered CETA cart, which will allow astronauts to slide themselves and their tools along the 350-foot truss of the station. Working with tools in the weightlessness of space can present its own unique challenges for astronauts.
The biggest thing that is different in space is that you really have to be careful about starting a rate. That is, if you start to spin around, you're going to keep spinning until you can grab something and stop that.
To provide an anchor point for astronauts, rigid tethers, portable work platforms, and foot restraints have been developed and tested, and will become a standard during station assembly. The space tools and equipment will assist astronauts with a primary task: to connect hundreds of wires and cables, creating a network for power, communications, fluids, and gases running along the outside of the station. Shuttle astronauts have already practiced and tested techniques in space to fasten cables and connect fluid and power lines. In addition, the Hubble Space Telescope servicing missions added important experience in making cable connections. Astronauts discovered that flexible bundles of cables can become as stiff as lead pipes in the chill of space, and the repetitive connecting tasks can cause hand fatigue when working in bulky pressurized gloves. New measures have been developed to ensure the astronauts' safety during space station construction as well. A primary concern is staying connected to the station. Unlike the space shuttle, the station cannot retrieve an astronaut if he drifts away. Astronauts have tested various types of tethers for station assembly, but should someone become disconnected from the spacecraft, a special space life jacket has been developed called SAFER. During flight tests for SAFER, astronaut Mark Lee found that no matter which direction he was turned, the SAFER could always help him find his way home.
You had an attitude hold, so you could hit the attitude hold, and what it would do is stop you. You may be stopping where you're looking out in deep space, and you realize, well, the shuttle's in back of me, so you turn around. Once you get references, then you can orient yourself and fly back.
Even with shuttle flights to prepare for station assembly, building a space station takes practice. The Neutral Buoyancy Lab at the Johnson Space Center has been called the biggest swimming pool in the world. The 6.5 million gallon facility was constructed specifically for astronauts to rehearse space station assembly tasks.
The best way that we have found here on the ground to replicate as best we can what it's like to actually be in zero gravity of space and be in your spacesuit and do an EVA or a spacewalk is to put a crew member into a spacesuit, put them into the water.
At 40 feet deep, the pool is large enough to house full-scale replicas of the giant space station components, providing astronauts a realistic setting for their training. During assembly, the astronauts won't be alone. They will be joined by robots. The shuttle's Canadian-built robot arm, which has demonstrated time and again its ability to deploy and retrieve large satellites, will be used to maneuver large pieces of the station.
For the big tasks, you get the robot to do it. Just like a construction site on Earth. You get the crane to lift the heavy piece, you put it in place, and then once it's in place, someone comes in and does up the bolts and plugs it in, and if something's not working right, they can get in there by hand and fix it.
Eventually, the space station will receive its own robot arm, also built by Canada. Representing the next generation in robotics, it will have more capabilities specifically designed for station assembly and maintenance.
It's got more joints, it's more articulating. In other words, it has the ability to bend in more places than the shoulder, elbow, and wrist that the shuttle arm has.
The new arm will even have the ability to attach itself on one end and disconnect on the other end, effectively inchworming across the station. A new robotic Canada hand can be attached to the end of the arm for work on intricate tasks that were impossible for past robotics. As robotic arms and hands assist during station assembly and maintenance, robotic eyes will give astronauts a new visual advantage. A small free-flying basketball-sized robot called AirCam will be used to conduct up-close site surveys of the station and assist in EVAs by broadcasting video back to station crews or ground controllers. The little robot's views may cut down the amount of time humans have to spend conducting spacewalks. Another set of eyes, called the Space Vision System, will provide far more than just pictures. Tested on several shuttle missions, the system uses targets, the shuttle's payload bay cameras, and a series of computers to create an artificial image of a module, providing precision information to the robot arm operator where it should be moved. The International Space Station will be covered with close to 250 Space Vision System targets to help astronauts with assembly. Just as astronauts rehearse on the Earth for spacewalking, robotic assembly operations must also be practiced. At the Johnson Space Center, astronauts use giant inflatable balloons to stand in for station modules, giving them a chance to practice robot arm operations. In addition, a domed simulator uses computer animation to allow astronauts to rehearse the assembly missions with realistic visuals. Training in the simulators and the real space experience gained from past shuttle flights are all coming together, preparing astronauts in the best ways possible for the assembly work that lies ahead.
We're considerably smarter. It's been an evolutionary process. We've continued to get better tools, better equipment, better procedures. We do have a tremendous challenge ahead of us. It's going to be one of the more exciting periods of manned space flight.
For facing those challenges, there will be rewards. The assembly of the International Space Station will create a state-of-the-art laboratory complex in space to study medicine, sciences, and the environment. A cooperative effort of 15 nations, it is the most complex international project ever conducted. Ultimately, the lessons learned and the technology developed from building the station will also help blaze the trail for further exploration beyond Earth's orbit.
It gives all of us working on carrying human presence farther into the solar system much more experience, and experience that really we can't do without if we want to go back out to the moon or way out into space to visit Mars one day. There's really an unavoidable path that you have to go through to gain that experience, and Space Station provides that stepping stone to go down that path.